In today's episode, we move into one of the most important skills in programming, control flow. This is where your code starts to think, to make decisions, to respond differently based on what's happening. We'll cover everything from simple if statements to nested, chained, and even advanced logical combinations that drive real back-end systems. By the end, you'll not only understand how to write conditions, you'll think like a back-end engineer, designing intelligent logic. Let's start with a foundational example that perfectly illustrates control flow in Python. We define a simple variable, temperature, setting it to 32. Here's our first condition. If the temperature is greater than 30, Python executes this line and prints "it's a hot day." Next is the elif, short for else if. This line is only checked if the first condition was false. If the temperature is above 20, it's a warm day. And finally, the else. This is the default block. If none of the conditions above it were true, the code falls through to this and prints, "it's a cool day." Every program runs in sequence, top to bottom, unless you tell it otherwise. Control flow allows you to break that sequence and decide what happens next. In this example, we're telling Python, if it's hotter than 30, say it's a hot day. Otherwise, if it's above 20, it's warm. Anything else is cool. Python checks these in order and stops at the first true condition. That's flow control in action. Let's explore a powerful concept called Truthy and Falsy values in Python. Here, the number 0 is treated as falsy, the condition fails, and the line won't execute. Conversely, the string hello is truthy. The condition passes and the line will print. Only empty strings, empty lists, the number 0, or none are considered falsy. In Python, conditions don't have to be strictly true or false. Every object can be evaluated as truthy or falsy. Numbers like 0, empty strings, lists, or none count as false. Anything else counts as true. This flexibility is powerful for writing compact logic. To create complex rules, we use logical operators like and or. We set up two simple variables, the user's age and whether they has ID. The AND operator requires that both sides of the condition must be true for the code to run. They must be 18 or older and have an ID. And not let us combine or reverse logic, and means both sides must be true, or means at least one side is true, not simply inverts the condition. These form the backbone of professional decision-making code. We can model complex, multi-step scenarios by nesting if statements. We set up our initial conditions for age and permission. First, we check the main gate, if they are an adult. Inside that adult check, we have a second nested if statement to check for permission. If they're an adult but lack permission, they are denied. The outer else catches anyone who failed the very first age check. You can also nest decisions, one inside another. This models complex logic, like multi-step authentication or layered approvals. For quick, single-line conditional assignments, we use the ternary expression. We start with an age of 17. This line reads like a sentence. The status is adult if the age is 18 or greater, else it's minor. We print the result, which in this case will be minor. A ternary expression is a one-liner decision. It's perfect when you want quick logic inside a variable assignment. Finally, let's look at the simple but useful pass statement. When Python requires an indented block of code, but you don't have the logic written yet, pass acts as a legal placeholder, telling Python to simply do nothing. Sometimes you want to plan logic but not implement it yet. Python requires an indented block, so pass acts as a placeholder. This helps when sketching complex flows. Now let's step beyond theory. Let's explore how these decisions work in real backend logic systems. A common backend scenario is role-based access control. We start with an editor user type. The highest privilege is checked first. Admin gets full access. Here we use a concise membership. Check with the in keyword. If the user type is found in this list, they get limited access. Anyone else, or any other role, falls to the default, getting view-only access. Here we're checking roles, a classic backend scenario. Instead of repeating multiple conditions, we can use membership checks like in to keep the logic readable. Let's quickly look at some common pitfalls beginners make with control flow. This is a classic logic bug often called shadowing. We check for adult status first. If the age is 70, the first condition, age but 18, is true. Python stops checking there, and the elif age now 60 condition is never reached. The logic is shadowed. See this? It looks fine, but there's a logic bug. Once age on 18 is true, the second condition never runs. Even if age is 70, always order your conditions from most specific to least specific to avoid shadowing. Logic, another key distinction, is between if and elif chains. This is a standalone if statement. This is a second, completely independent if statement. If the score is 100, both statements will print, because they are not connected by elif. Also remember, separate if statements run independently, while elif chains are exclusive. That distinction is crucial when designing multi-condition systems. Let's bring everything to life with 3 smart projects, all using control flow to solve real-world backend problems. Alright, let's start with our first project, the Smart Login Validator. This one simulates a real-world security check, combining multiple layers of conditional logic. We begin by printing a clear title for our project. We take our 3 main inputs, the username, password, and a simple check for 2FA. This first if statement is pure validation. We use stripping to handle accidental spaces, and the OR operator ensures that if either is empty, we print an error and stop. If the credentials aren't missing, we check if they match our stored admin credentials, using the AND operator because both must be correct. Now, inside the successful login, we have a nested if. We check if the user claimed to have 2FA enabled. This creates a third layer of logic. Only if the 2FA code is correct is final access granted. This is how multi-step security works. If 2FA wasn't enabled, they get access immediately after the primary credentials check. Finally, the outer else catches anyone who failed the primary username and password check. This layered approach is essential for secure backend systems. Our second project is the Loan Eligibility Checker. This showcases how you can use chained elif conditions to model tiered business logic, like a bank's approval process. Again, we start with a clear project heading. We take our inputs, income, credit score, and employment status. We wrap all of this in a try, except block to make our code robust against non-numeric input. Our first if is a sanity check. Income and score can't be negative. We use or to check for either condition. The first elif checks for the most specific highest tier, high income, high score, and employment. All 3 must be true due to the AND operators. If they failed the premium check, we move to the next tier, a lower threshold for a standard loan. And finally, the entry-level starter loan requirements. If a user fails all the specific elif checks, the final else gives them the rejection message. And here is the accept block that cleanly handles the case where the user typed in text instead of a number, preventing the program from crashing. Finally, we're building a dynamic discount engine, a common pattern in e-commerce backend logic. This one uses ternary expressions to keep the code concise. We start with our title. We take the purchase amount, check for loyalty membership, and ask for an optional promo code. Here's the first piece of logic. If they are a member, the discount is set using a ternary expression, 15% if the purchase is big, otherwise 10%. The else block handles non-members. Also using a ternary, they get a smaller 5% discount only for larger purchases, otherwise 0. Crucially, this is a separate if statement, not an elif. It runs after the base discount is set and adds an extra 5% if the specific promo code is entered. This shows how to layer independent rules. Now we calculate the final price by subtracting the total accumulated discount from 1 and multiplying that by the purchase amount. Finally, we print the results. This demonstrates how to combine conditional assignment and independent logic to execute complex business rules efficiently. And that's the complete guide to control flow in Python. Mastered. You now know how to write intelligent decision-making code with if, elif, else, logical operators, and nested logic. These skills are the foundation of every backend rule engine you'll ever build. In our next episode, we'll move into loops, where your code will not only think but repeat actions intelligently. Don't forget to like, share, and subscribe to AI and Digital Skills Hub, where we build your backend brain, one project at a time.